Okay, naming ionic compounds containing polyatomic ion. A polyatomic ion is a negative ion or a positive ion that contains more than one element. There's one positive, one that's usually in a compound, and that is the ammonium ion. Ammonium ion. The rest are all going to be negative. Now, the parent ion for polyatomic ions is the most common oxy ion for that element. So, PO4, 3-, is the parent ion for phosphorus. So it's called phosphate. All of the parent ions contain part of the element's name and then the end in ATE. So, NO3, 1- would be nit for nitrogen, and then 8 because it's the most common. So 8. All of the most common ones, the parent ions, end in 8. What happens is sometimes you can have polyatomic ions with one less oxygen in them, but the same charge. For sulfate, you can spell it with an F or you can spell it with a PH. It doesn't matter which one. Okay, so NO2, 1- has one less oxygen than the parent ion, so the beginning part is the same, but it has an ite ending. So SO3, 2- would be sulfite. We call these ions that have oxygen as part of their formula, we call these oxyanions because they are negative ions, so that's where the anion part comes in, and the oxy means containing oxygen. Now, the halogens have a couple of extra ions that they can have. So, again, if it is the parent ion, it is the halogen name ending in ATE. And for the halogens, it will be 3 oxygens, like ClO3 -1. So this would be called chlorate. The chlorate ion. If it has 2 oxygens, it is ClO2, 1-. So the ending, again, like I've just explained, is ite. So this is chlorite. Now, there's 2 more ions they can have. They could have 4 oxygens in their compound, so 1 extra. The naming rule now becomes per in front of the parent name. So an example is perchlorate. And if there's 1 oxygen, then there's another prefix. It's hypo, and it's still ite. So this would be hypochlorite. And this rule applies for the halogens only. What I suggest is you highlight all the 8 ions in the table that I gave you. And that'll make for a quick reference. So use the reference chart when you are naming your polyatomic ions. Not all of them end in 8. We have hydroxide and cyanide that just end in IDE. Okay, so the chemical formula for our first example, let's do, okay, CuSO4. So this is copper. Copper is one of our multivalents, so it's something. This is the polyatomic ion for sulfur, that's the parent, the most common, so it is sulfate. So let's figure out what the charge is on copper. Sulfate has a 2 negative charge. There's only one SO4 in our formula, so the total positive has to equal the total negative, so this is copper 2 sulfate. Okay, so this metal is calcium. It's not one of our multivalent metals, so we don't need to include Roman numerals. And this ion is nitrate, so this is just calcium nitrate. All right, NH4 is ammonium, and CO3 is carbonate, so it's ammonium carbonate. It's pretty straightforward, just like really naming the binary, except you do have to pay attention sometimes if you've got a multivalent metal.